Namaste, welcome to Pythagoras Academy. Sometimes terms like d v bar by dt, d mod v bar by dt, modulus of d v bar by dt will be very confusing to students. This video will clear all the misconceptions about this terminology. Let us have a look of these expressions. So d v bar by dt. If you have any vector a bar, it means it has got a magnitude as well as direction. The magnitude of the vector is represented with the symbol modulus. The modulus operator is used to talk about the magnitude of a vector. So when I say d v bar by dt, suppose where v bar is velocity. So I'll define v bar is velocity. Then dv bar by dt, d modulus of v bar by dt, modulus of dv bar by dt. We should have 100% clarity of interpreting these kind of terms, especially in kinematics. So look at the definitions. What is dv bar by dt? What does it read? It is rate of change of velocity with respect to time. And what is d mod v bar by dt? It is rate of change of magnitude of velocity. As I said, modulus is used to talk about the magnitude of a vector. D mod v bar is rate of change of magnitude of velocity, which is nothing but speed, because magnitude of velocity is nothing but speed with respect to time. And what is this? dv bar by dt is a vector which is rate of change of velocity with respect to time, which is acceleration. So modulus of dv bar by dt is nothing but magnitude of rate of change of velocity with respect to time. Magnitude of change of velocity with respect to time. So look at these two expressions. This is rate of change of magnitude of velocity with respect to time, whereas this is magnitude of rate of change of velocity with respect to time. So this is basically rate of change of speed with respect to time. This is magnitude of acceleration, because dv bar by dt is acceleration. This is magnitude of acceleration. Basically, velocity is a vector. It has got two components, magnitude and direction. When I do dv bar by dt, I'm talking about rate of change of velocity. It means the rate at which the magnitude as well as direction changes with respect to time. So d modulus of v bar by dt is a part of this, isn't it so? Because this velocity v bar has got mod v bar, which is magnitude, and direction. So this particular term d of modulus of v bar by dt is only talking about how the magnitude alone is changing, whereas this first one, this is talking about how both magnitude as well as direction are changing with respect to time, which is acceleration. Whereas the third one is talking about the magnitude of acceleration. We are not bothering about the direction of acceleration here when I keep modulus. So this dv bar by dt is a new vector a bar. This new vector again has got both magnitude as well as direction. So this particular term, modulus of dv bar by dt, is only talking about the magnitude of acceleration mod a bar. To understand it better, I'll give you two questions to answer. Now look at these questions. Number one, if rate of change of magnitude of velocity with respect to time is 0, it means mod v bar is constant. It means the speed is constant, the magnitude of velocity is not changing. If dx by dt is 0, it means x is not changing with respect to time, x is constant. So d of mod v bar by dt is 0. So what does it mean? Modulus of v bar is constant. the speed is constant. If the speed is constant, then what about dv bar by dt, which is nothing but acceleration? If the speed is constant, can I also say that dv bar by dt is 0? If I say dv bar by dt is 0, what I am actually saying, I'm saying that v bar is constant. Basically, this question is asking you, if modulus of v bar is constant, can I say v bar is constant? No. If modulus of v bar is constant, the magnitude of velocity is constant, but the direction can change. The best example to this is uniform circular motion. In uniform circular motion, at every point, the magnitude of velocity is v. The speed does not change, it is v, but the direction is continuously changing. So uniform circular motion is a case where d mod v bar by dt is 0 because speed is not changing, but dv bar by dt is not equal to 0 because the direction is changing. This says that speed is remaining constant. This says that velocity is changing. Speed is constant, but velocity is changing. It is possible. Why? Because the direction alone is changing. So the answer to this is may not be 0. And coming to the second statement, if dv bar by dt is 0, it means acceleration is 0. It means v bar is constant, velocity is constant. If v bar is constant, then both magnitude and direction of velocity are not changing. Magnitude is not changing and direction is not changing. If direction is not changing, it means the path is straight line path. If this is given, it means it is straight line path. The information that the particle is executing straight line path is stored in this mathematical form dv bar by dt is 0 because velocity is not changing, v bar is constant, the vector itself is constant, magnitude and direction both are constant, so it moves in a straight line path with constant magnitude. So magnitude is also constant. So this implies this. So this is 0, magnitude is also constant. But if magnitude alone is constant, I cannot talk about direction. But if both magnitude and direction are constant, then I can say the magnitude is also constant. So the change of magnitude with respect to time, so this is 0. So this is the understanding of these pretty confusing terms. So basically it's all about comparing velocity and speed. So there is a chance of speed remaining constant but velocity changing. But there is no chance of velocity remaining constant but speed changing, because if velocity is constant, definitely speed is also constant. So hope you understood this video. If you have any questions, you can always ask me in the comment section. Thank you so much.